We're going to find the limit of a function by using the Squeezing theorem. The Squeezing theorem is used when the limit of a function is difficult to find, but its value is between two functions that the limit can be found. For instance, if f of x is difficult to find, but we know it's between two functions g of x and h of x, and we know that g of x and h of x have the same limit L, then f must also have L as its limit. The Squeezing theorem is sometimes called the two officers and a drunk theorem. If two police officers are escorting a drunk prisoner between them, and both officers go to a cell, then the prisoner must also end up in the cell. For example, let's find the limit of sine x over x as x goes to 0. This limit is very difficult to find directly, so we will use the Squeezing theorem. Let f of x be the area of a unit sector OBP. So draw the sector where O is at the origin, B is at 1, 0, and P up here will be at the cosine x and the sine of x. And x is the radians of that angle. The area of a sector is 1/2 r squared theta, where in this case theta will be x. So the function of x, or function will be the area, is equal to 1/2 radius is 1 squared, and the theta will be x. So all this will be equal to 1/2 x. Let g of x be the area of the triangle OBP. Where the area of a triangle is equal to the 1/2 base times altitude. G of x then becomes 1/2 1, which is the base, and the altitude is sine of x. So g is 1/2 sine of x. We'll let h of x be the area of the triangle OBQ, or OB, and Q will be the vertical line above B. Remember, this is the sector, so we can see that this triangle QB will be larger than the area of the sector. The area of the triangle, again, is half base times altitude, so this area will become 1/2 the base, which is 1, and the altitude in this case will be the tangent of x, where tangent is rise over run. So we have the area of the first triangle is 1/2 sine x. That's always going to be less than the area of the sector, which we found to be 1/2 x, which is always going to be less than this larger triangle, which is 1/2 tangent of x. This sets it up nice for the squeeze theorem. We do a little algebra by multiplying through by 2 over sine of x. And this will become 1 is less than or equal to 8 x sine of x less than or equal to 1 cosine x. We take the reciprocals and we get cosine of x is less than or equal to sine of x over x is less than or equal to 1. Now we know the limit of cosine of x as x goes to 0 is equal to 1. Plug that into here and we get 1 is less than the limit of x goes to 0 of sine x over x is less than or equal to 1. So this function here, since it's between these two, that we know it's 1, then we know that the limit of this function as x goes to 0 of sine x over x is equal to 1. If you have any questions, feel free to post it in the comments. Thank you very much for watching. Bye-bye.